In this lesson, we look at two things. One is what's called the converse of the Pythagorean theorem. And then the other thing that we do is we take the Pythagorean theorem and we apply it to the coordinate grid to find distance between two random points. So the sentence in the top of the page says, if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. And that might sound very similar to the Pythagorean theorem, but it's the Pythagorean theorem in the reverse order. And you're like, well, duh, I mean, like, who cares? Not a lot of math statements can be reversed like that. And so it's very powerful when a statement can be reversed and still be true. For example, you can say, if you're on the green team, then you're in 8th grade, but you can't switch it around and say, if you're in 8th grade, then you're on the green team. So not a lot of statements can be switched like that, but the Pythagorean theorem can. So what we do is we don't know if it's a right triangle, but we want to see if it is. We have our measurements, right, over here in example 1. So what we do is we take our theorem and we plug it in. So remember, the theorem is a squared plus b squared equals c squared. And remember, the hypotenuse is always the longest side. So this 41 is the C value, and then it doesn't matter what you plug in for A and B, so we'll do 9 here and 40 in B, but it doesn't matter, you could have reversed it. And so we get 81 plus 1600 equals 41 squared is 1681. So obviously this does check because I get the same thing on both sides. So then the answer is, yes, it is a right triangle. All right, now when you look at example B, it might look obvious to you that it's not a right triangle, but there's a couple things I need you to understand. Not all pictures in geometry are drawn to scale. That's one thing that you have to remember. So for example, the relationship between 12 and 18 might not be exactly proportional. And we're not going to get out a ruler and measure because I know this isn't actually 18 feet. So that's one thing. It's not always drawn to scale. Sometimes we just draw a random shape and put numbers on it and it doesn't mean anything. Another thing is that this might be drawn at a different perspective. So if you think about like art class, right? You might be looking at this from far away or from a different angle. And so if you look at it kind of flat, if you can see the perspective, this could maybe be a right angle if you're looking at it from a different perspective. And the third thing is that your eye can't necessarily tell if something is exactly a 90-degree angle. It might look like a 90 because it might be an 85 or a 92, right? And so you don't necessarily know for sure unless you have that right angle box. So the only thing that we can do is we can recognize that this is the hypotenuse because it's the longest side and plug it into the Pythagorean theorem. So I've got a squared plus b squared equals c squared. And so this is 24, and it doesn't matter which piece goes in where, so I'll do 18 squared plus 12 squared. So I get 324 plus 144 equals 576. Use your calculator to get these values. So obviously this isn't correct because you get 468 equals 576. So then our answer is no, it is not a right triangle. All right, let's take our idea and bring it onto the coordinate grid. So we go to example 2. It wants us to find the distance between these two random points. So what I'm going to do is I'm going to make a sketch. And I'm going to plot the points. So here's 1, 5. And -4, -2. And what they want is they want the distance between those 2 points. Now in algebra next year, you're going to learn about this thing called the distance formula. But what you can do is you can drop this down and bring it over, and then you have a right triangle. So we can find the measurement of this side right here and the measurement of the height. and plug it into our formula. So the measurement of the base is 5 units, right? Because you can just count boxes. And the measurement of the height is 7 units because you can just count boxes. And so we get 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. And then when I add, I get 74. So I'm just going to round. I'll get my calculator out and type that in and round it. I believe it's around 8.6. So we say 8.6 units. If you want to try the next one on your own, go for it. If not, follow along with me. I'm going to make my grid. And plot the points. So I've got 7, -3. And 9, 6. So if we want to find the distance between these points, let's turn it into a triangle. Drop that down, bring that over. There's your right angle. The distance here is 2. And the distance, the height is 9. So we go to the theorem. 2 squared plus 9 squared equals c squared. 4 plus 81 equals c squared. So we've got 85, and then we take the square root of 85. 9.2. So we've got 9.2 units. All right, let's look at an application of this. Pause the video, read example 3, and when you're ready, play. So the question is asking, is this angle right here a right angle? So we have to figure out if this works in the Pythagorean theorem. So I have to find the distances. If they're asking me, is this a right triangle, then I need to know the measurements so I can plug it into the formula. So here we go. When you find these distances, we're going to count by tens. So let's start right here at the turn, okay? And I'm going to count up and over to find the lengths of the legs, and then I'll use my formula for D1. So if I go up, it goes up 10, 20, 30, so that's up 30. And then right 10, 20, 30. So plug that into the formula. 30 squared plus 30 squared equals c squared. All right, so let's do this. Let's just finish it up. 900 plus 900 equals c squared. So I get that c squared equals 1,800. And when I go to take the square root, you get some weird decimals. So just go with me. It's going to look a little weird right now. Let's leave it as just the square root of 1,800. Let's not actually get the decimal. All right. So now let's move on to D2. So I'm going to start at this turn, and I'm going to go down and to the right. So I'm going to go down 10, 20, 30, 40, 50. And then I'm going to go to the side, also 50, 10, 20, 30, 40, 50. So I get 50 squared plus 50 squared equals c squared. All right, pause the video and do it like we just did the other one. Don't get the decimal, just leave it as a square root. All right, so I got that c equals the square root of 5,000. Just play along and you'll see how it all works out at the end. So now we have to do D3. That's our last one. So we're like pros at this now, right? Okay, so we're going to count by tens. So 10, 20, we're going 20 to the side. And then I go down 10, 20, 30, 40, 50, 60, 70, 80. So I have 20 squared plus 80 squared equals c squared. Pause the video and finish this one as well. All right, so here we are. We have all the measurements, but that's not what the question wanted, right? We did all this work and we didn't even answer the question. What the question wants to know is, did your friend make a 90-degree turn? So essentially it's asking, is this a right triangle? So what we have to do is we have to take our values for the distances and check to see if it works in the Pythagorean theorem. So I'm going to take the square root of 1800 squared plus the square root of 5,000 squared and see if that equals the square root of 6,800 squared. Now you might say, how do you know 6,800 is the hypotenuse? And the answer is, well, it was the measurement for D3, so that would be our guess for the hypotenuse. The other thing is that it's the biggest number. So now I asked you to leave it as radicals because a magical thing happens. Remember all the way back when we learned about order of operations and how squares and square roots undo each other? This square root is actually the opposite of this squaring. So they actually cancel each other out. So all we have is 1800 because the square and the square root are inverses. And this is just 5,000. And this is just 6,800. So you see, rather than deal with all those annoying decimals, it made it way easier to calculate. And now you can obviously see that they're equal to each other. So then the answer is yes. Now here's a fun fact. If you remembered anything about slopes of parallel and perpendicular lines, these two have negative reciprocal slopes. And negative reciprocal slopes are perpendicular, and so perpendicular means makes a 90-degree angle. So see how all the chapters circle back around into each other? So D1 and D2 are actually perpendicular because they have negative reciprocal slopes. But you can also do it using the Pythagorean theorem. And if you have any questions, write them down and ask me when you come to class.